Hello, my name is Abiodun Anifoshe. I'll be teaching you organic chemistry, and today we're going to start with the introduction to alcohols and phenol. There are different kinds of compounds in organic chemistry. Based on the functional groups that are present in the compounds, we have classified them into different classes. We have the alkanes, the alkynes. We have the aldehydes and the ketones. We have the alcohols and the phenols. We have the carboxylic acid and the derivatives. We have the amine, we have the amino acids and the peptides. We have carbohydrates. We have different classes of organic compounds in organic chemistry. But we are going to start with alcohols and phenol. And this is just going to be an introduction to alcohol and phenol. And we're going to start by looking at what makes this compound alcohol and what makes them phenol. So basically, there is something we call the OH group, which is called the hydroxyl group. It is called the hydroxyl group. So in organic chemistry, when you see the functional group OH linked to any group, then you know that we have an alcohol or a phenol depending on the group that it is linked to. So we can represent the group as R, and then we have OH linked to it, or we have an aryl group and we have OH linked to it. In this case, we say we have an alcohol. In this case, we say we have a phenol. And I've summarized that on the sticky note to the left of the board. As you can see, this is the OH group, the hydroxyl group, and then this is ROH, which is, in this case, the R is used to denote alkyl group. In organic chemistry, as you may know, when we say we have an alkyl group, we are basically talking about this group here, which can be CH3, it could be CH3, CH2, and it can be a long alkyl group chain. And when we have the aryl group, we're basically talking about this group, the benzene group that has one of the hydrogen atom removed, because it is serving as a substituent in this case. So we're not having, instead of having the benzene, which is C6H6, we are now having C6H5. So this is used to denote an aryl group, and it is written this way for short. And then you can say AROH, which is used to denote a phenol. So in this case, we use ROH to denote alcohol, and we use AROH to denote phenol. And as you can see, we have different kinds of alcohols. In organic chemistry, we have a lot of compounds that are classed as alcohol. Just look out for the OH group. When you see the OH group, then you know that the compound can be classified as alcohol. And in this case, we have ethanol with a CH3CH2OH as the molecular formula. Also, just so we are on the same page, when you see something like this in organic chemistry, like I said, this is ethanol, and it's just in the skeletal form this way. So we can break it down so that we know what this is made up of. So if we are to write the molecular formula of this, it's the same thing as CH3CH2OH. So this is ethanol, but this is the skeletal form. So, but in most cases, you're not going to see the formula as this. You're just going to see the skeletal formula of the compound you are dealing with. So in this case, we have ethanol, and ethanol, it's a common common alcohol that is often used in the industry and also in making the popular alcohol that we drink. And we also see here cyclopentanol. So this is a cyclic alcohol. Cyclic because it's a closed ring here. It's an alkyl group though, but it is closed. So it is a cyclopentanol. We have 5 carbon atoms, 1, 2, 3, 4, 5. Then this carbon has an hydroxyl group attached to it. So this is ethanol, this is cyclopentanol. They are both alcohols. And there are a number of alcohols that are found in natural products. As we can see here, we have grandisol. Grandisol is a natural product that is actually a hormone that is found in the male cotton boll weevil. It is the sex, excuse me, it is the sex hormone that is found in the male cotton boll weevil. It's an alcohol, as you can see the hydroxyl group that is in the molecular formula of the molecular structure of the compound. This is the compound called grandisol. And in most cases, if you are dealing with an alcohol, you will, for the most part, you will have the compound name end in OL. The compound name in most cases for alcohol will end in OL, in the suffix OL. Even though we've not talked about these ones here, you can see already, this ends in OL, chloramphenicol. This ends in OL, geraniol. They are both alcohols as well. And the chloramphenicol, this chloramphenicol, it's used as antibiotics. It is isolated from streptomycin venezuelae. So this is a compound that is extracted from natural source. It is used as antibiotic. It's an alcohol. And this one, geraniol, it's often used in making perfume. It is isolated from roses and geranium. So it's also an alcohol, as you can see the hydroxyl group here. So these compounds are all alcohols. And you can see phenol, it's a little bit different from the alcohol, even though it also has the hydroxyl group. As you can see here, we have the hydroxyl group, but then instead of us having just an alkyl group, most times you see alkyl group, like I said earlier, represented by a CH, and the CH can be CH3, CH3 can be CH3, CH2. I mean, the alkyl group can be CH3, it can be CH3, CH. It can be a short alkyl group or a long alkyl group. So basically, alkyl group can be any combination of carbon and hydrogen atoms that are linked together and mostly saturated, but you could also have unsaturated alkyl group. That is, they have alkene and the alkyne, or the alkyne in their structure. So like I said, you can have unsaturated. Okay, I don't even need to draw. So you see this one, geraniol. In this case, we have the alkyl group like this, and this is the hydroxyl group. So we said alcohols are always like this. So we have the alkyl group and the OH group. So in the case of geraniol, this is the alkyl group. This is the hydroxyl group, and this is the alkyl group. And this alkyl group, in this case, it's an unsaturated alkyl group because it has double bonds. The double bonds makes it an unsaturated compound. So that is that about that. So like I said, in the case of phenol, instead of having alkyl group, we have an aryl group. And it's just a benzene ring. Phenol is just a benzene ring that is linked to an hydroxyl group. As you can see here, you can trace my pointer to the board. So you see the hydroxyl group is directly linked to one of the carbon atoms in the benzene ring, and that makes this a phenol. So we have other phenol or derivatives of phenol and compounds from natural sources that are derivatives of phenol, and I have listed a few examples here. You can see dopamine. Dopamine is actually is a derivative of catechol, amino catechol. So in chemistry, when we say catechol, catechol is also itself is a derivative of phenol. So when we have something like this, we say we have catechol. This is catechol. A catechol will be a benzene ring that has two hydroxyl group linked to two of the carbon atoms in the ring. Excuse me. So this is catechol. This is amino catechol, and it is called dopamine. Dopamine is very important to human brain and the body. It is both a hormone and a neurotransmitter. It is responsible for most of the things that goes on in the brain, and it's something that has been said to be absent in Parkinson's diseases. So dopamine is also an alcohol that is present in natural products. I mean, that is a natural product. Also, capsaicin. Capsaicin, the compound here is called capsaicin. It's also a natural product, and it's been found to be responsible for the spicy hot flavor that is found in chili. It is responsible for the spicy hot flavor found in chili, and it is this compound. It is called alcohol. I mean, it is an alcohol. It's an alcohol. So also this compound here, it's an alcohol. It's obtained from natural source, and in fact, this is obtained from the well-known marijuana. This is obtained from the well-known marijuana. It's also an alcohol. It is called tetrahydrocannabinol. Tetrahydrocannabinol, abbreviated to THC. So this compound is actually it's been found to be the psychoactive drug in marijuana. This compound here, it's the psychoactive drug that is found in marijuana. It's also a natural product, and as you can see, all these compounds are alcohol among a plethora of alcohols that we have in nature, in both plants and animal. We have a lot of alcohols. So the study of alcohols and phenol is worthwhile. And so we're going to move to the nomenclature of alcohol. Nomenclature of alcohol. In chemistry, we talk about nomenclature because it is very important. And nomenclature simply means that how do we name these compounds? What are the rules that guide us to naming this compound, the compound of interest? How do we name it? So in this case, our compounds of interest are the alcohols and phenol. But mostly we're going to look at the nomenclature of alcohol in this chapter. I mean, in this lecture. But we're going to be looking at the nomenclature of phenol in detail later on in the future lecture, because of space limitation and time limitation. And so let's just jump into the nomenclature of alcohol. So the first thing you look out for is the parent name. What is the parent name of the structure you are dealing with? So I have listed, okay, let me just go through all the rules before we start analyzing how we use those rules and what we look out for. So the first rule is to identify the parent name, which must include the carbon atom to which the hydroxyl group is attached. You identify the parent name including the carbon atom to which the hydroxyl group is attached. The second thing is to number the alkane chain starting from the end close to the hydroxyl group. I will explain all that in a moment. The third thing you do is to number the substituents and place substituent locants before the parent name. Then the last thing is that the OH locants should be placed just before the parent name or the suffix OL. And what we mean by locant is just the location of that particular group in the structure, in the molecular structure of the compound in question. So how do we apply this rule? Let's take a look at this example. This is an alcohol. It's actually pentanol. So based on the first rule, it says identify the parent name. Usually the parent name is derived from the longest carbon to carbon chain in the molecule. And in this case, if we look at the compound, the longest carbon is actually 5. As we can count it, 1, 2, 3, 4, 5. That is 5 carbon atoms. There is no other way to count the carbon atoms in this molecule. And actually, you can see that we already included the OH group in our counting because it's just a straight chain compound. So it is simply pentanol. This compound is simply pentanol. So this compound is pentanol. I'm trying to avoid this thing from removing from my cloth. So this is my microphone. Okay, so this is pentanol. It is 1, 2, 3, 4, 5 carbon atoms. It is easy to identify and it is pentanol. And I believe we remember, and if we don't, we remember how we name carbon atoms in alkane. We have the methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So just so we're on the same page. But if you don't remember, you can quickly brush up on arcane chemistry. But I'll be talking about arcane chemistry later on. So let's move to this one in appreciation of the rules of naming alcohol. This compound, we're trying to name it. The first rule is to identify the parent name. So what is the parent name here? We said we have to look out for the longest carbon to carbon chain. If we start counting, we can take a look at it this way. We'll say 1, 2, 3, 4, 5, 6, 7, 8. That seems to be the longest carbon to carbon chain. But does it include the hydroxyl group in the membrane? The answer is no, because the carbon that is carrying the hydroxyl group is not in any of these carbon atoms that we have numbered, that we have counted. This is the carbon bearing the hydroxyl group, and so it must be included in our nomenclature, in our straight longest carbon to carbon chain that we're going to include in naming this compound. And so we are going to disregard this direction. We're not going to include this. We can actually include it, but we are going to actually make sure that we include this carbon. That is the goal. So we can either go this way or we go this way, whichever one is longer. So if we go this way, it's going to be 1, 2, 3, 4, 5, 6 carbon atoms. If we start this way, it's going to be 1, 2, 3, 4, 5. That is 5 carbon atoms. So which is the longest? This one, of course, including the hydroxyl group. So this would be, so then it will be 1, 2, 3, 4, 5, 6. And that means our longest carbon to carbon atoms in this compound is, let me write it here. It's hexane. But let me just remove the E because we don't intend to have E in an alcohol, because it's an alcohol, is going to end in OL. It's going to be maybe hexane, whatever all. The hull will have its own position. That is, what is the position of the OH group? That is where the locant comes in. We're going to get to that. So it's going to be hexanol. But then, are we going to start from here or are we going to start from here? Now that we have established that this compound has to be like this, the straight chain or the longest chain has to include all this carbon. Are we going to start from here or start from here? Now, the answer to that is found in the second rule of nomenclature of alcohol, which states that number the alkane chain starting from the end close to the hydroxyl group, which suggests that we are supposed to start from here. And so, to start from here will make us have something like this. 1, 2, 3, 4, 5, 6. So that means we're going to start from here, and that puts the locant of the OH group as 1. That is, the location of the OH group is what? Is the number 1 carbon. And any other thing that branch out of the longest carbon to carbon chain will be a substituent. It's going to become a substituent. So in this case, this is a substituent, and this is the longest carbon to carbon chain. 1, 2, 3, 4, 5, 6. But actually, we're starting from here. So 1, 2, 3, 4, 5, 6. So this is hexane 1-ol. So this is hexane 1-ol. I'll just write it here. Hexane 1-ol. But that is the parent name. There is a substituent here. This substituent is a 3-carbon alkyl group, and a 3-carbon alkyl group is going to be called what? It's going to be called propyl. So the substituent is propyl hexanoid. It's propyl. It's propyl. But we're not just going to write propyl hexanol, because the propyl location has to be included in the name of this compound. So how do we know the location of these propyl substituents? It's easy. So we just take a look at the numbering. We started from here: 1, 2, 3, 4, 5, 6. So this second carbon is the one that is bearing the substituent propyl group, and so it becomes 2-propyl hexane 1-ol. 2-propyl hexane 1-ol. And what that means is that we have a propyl substituent on the second carbon in this molecule. And the second carbon in this molecule, according to the nomenclature rule of alcohol, is this carbon. And the OH group is, according to the nomenclature rule of alcohol, is located on the first carbon. So it's going to be hexane 1-ol. And according to the the fourth rule, the OH locants should be placed just before the parent name or the suffix OL. That means that this compound name, this name here, can be rewritten. We can also write it this way. So for this compound that we named as 2-propyl hexanol, hexane 1-ol, we can also, so we can either write it as 2-propyl hexane 1-ol, or we say 2-propyl 2-hexanol. So we can, 2-propyl 1-hexanol. That is one that we have here. So because the OH group is attached to the first carbon atom in the parent structure of the molecule. So either 2-propyl hexane 1-ol or 2-propyl 1-hexanol is correct. Both of them are correct. So also if we have just one, if the position of the OH group is 1, we can just remove the 1 and just say we have 2-propyl hexanol without the 1. And when you write it like this, what you're saying is that the OH group is located on the first carbon atom in the molecule. And that's that about that. So in appreciation of this rule of naming alcohol further, we're going to look at this molecule that we have drawn here. So if you look at this, we have an hydroxyl group attached to the second carbon atom that is starting from here. But if we start from here, this hydroxyl group is going to be found on the 6th carbon atom. So in appreciation of that second rule of naming alcohol, which one do you think is correct and which one is wrong? So to appreciate the second rule of naming alcohol, we will say that this is right and this is wrong, because this starts from the side that is closest to the hydroxyl group, whereas this starts from counting from the side that is further away from the hydroxyl group. Starting from here, we put this OH as let's count the longest carbon to carbon chain: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So we can say the longest carbon to carbon chain is 7. If we go this way, it will also be 7. So we can go this way, because in this case, we actually need to include this alkene functional group. We'll talk about that, about preference, when we get to the alkene chemistry. So we're going to include this, and then it's going to be 7 carbon atoms in this chain, and that we put this compound as heptanol. Heptanol because we have an alkene group here, but then the ol will be the preference here, will take more priority, and that will put this compound as the ol will end in this compound will end in 2-ol, whereas this one, we naming it from this side, we put this OH as 1, 2, 3, 4, 5, 6-ol. So we'll take this one over this. We'll take 2-ol over 6-ol, and that makes this nomenclature correct. That is starting from this direction instead of this direction. And if we look at the next one, let me cancel this, but I'll just still leave the structure just for reference purpose. We say this is right, this is wrong. If we look at this one, this is actually 3-pentanol, because either way, this hydroxyl group will be on the 3rd carbon atom. 1, 2, 3, 1, 2, 3. So that puts this hydroxyl group on the 3rd carbon atom, and then the name of this compound becomes 3-pentanol, or you say, yeah, that is it here, or you say pentane 3-ol, pentane 3-ol. So either of these is right, or we say both of these is right. So anyone you want to use, but I prefer to go with this, because it tells anyone that is looking at this compound name that the OH group is on the 3rd position, even though this says the same things, but I think that is personal preference. So talking about the nomenclature of cyclic alcohol. For cyclic alcohol, the carbon that is bearing the hydroxyl group, they automatically take precedence over other carbon. So that means that you are going to start naming the compound from that particular carbon. So this automatically becomes 1, and the rest, it continues like that. And also you can consider the substituents such that the substituent has a lower value, a lower number for the locants. That is, the number that you're going to use to locate the compound has to be the smallest possible. Okay, let me cite an example to appreciate that. So to appreciate what I just talked about, let's say we have something like this. Oh no, I want something with 7 carbon atoms. Let's say we have something like this. Now this is how many carbon atoms? We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So this automatically become number 1 carbon, and we can say 2, 3, 4, 5, 6, 7. If we go this way, this compound name is going, okay, the parent name for this compound, first of all, the parent name for this compound, let's slow down here. The parent name for this compound has to be derived first, and that will be the longest carbon to carbon chain. If we look at it, since it's a cyclic structure, it's 7 carbon atoms, and that put this compound parent name as cyclopentanol. Cyclopentanol. But then, because the carbon bearing the OH group has to take the precedence over any other carbon, so that makes this not cyclopentanol. It's 7 carbon atom. That is cycloheptanol. Hept is for 7, 5 pent is for 5. So in this case we have 7 carbon atom, and that makes it heptanol, cycloheptanol. So then we have a substituent. This substituent is a methyl group. We have 2 methyl atoms. 2 methyl groups here. We have one here, we have one here. So we have two methyl groups. We have to name them also, naming them in the sense that we have to represent them by their location in the name of this compound. So if we are looking at it this way, we can, if we are naming it this way, it will put this following this direction, we put this compound, this locant on the 6th position, 6th carbon atom, and that will be 6,6-dimethyl cycloheptanol. But according to the nomenclature, the rule, we can't follow that direction. We have to give the substance a location that is the least location number possible, and that means that we have to go follow this direction, and that will put this substance on the 3rd carbon atom. That means we have 1, 2, 3. So this will be the 3rd carbon going this way, but going this way, this will be the 6th carbon. So we have to go this way so that we have this substance on the 3rd carbon, and that will make this substance to be on the 3rd position, and that will give this compound the name 3,3-dimethyl cycloheptanol. So that will be the name of the compound. Let me write it here. I'll write it here. 3,3-dimethyl cyclopentanol. Oh, sorry, why do I keep writing pentanol? Oh gosh. Okay, cycloheptanol. Hept because we have 7 carbon atoms. So 3,3-dimethyl, that is, we have a methyl substituent on the 3rd carbon atom, and not just one methyl, we have 2 methyl groups, and they are both on that same carbon, and that's why we have to repeat the 3. We have to say the 3 twice because there are 2 methyl groups on that 1 carbon atom, and that makes it 3,3-dimethyl cycloheptanol. If you have any concern or any question relating nomenclature of alcohol, you can ask me. If this video gets to YouTube, you can ask me in the comment section. If it's wherever the video finds itself, you can ask me. I believe there's going to be a comment to interact on the platform that I'll probably be posting it on. So that said, let's look at the next thing here, which is the glycol. So this compound is glycol. So I just put this here to tell you that we can have more than one OH group, more than one hydroxyl group, more than one alcohol group in a compound. And this is an example. It has 2 OH group. It's called glycol. So sometimes some people can call it ethylene glycol because it's made from ethene. It's made from ethene, and it has 2 OH group. So this is glycol. We can also have 3 OH group in one single molecule, like the glycerol. So we have, it's possible to have multiple OH group in a compound, just like this one. We have 2 OH group in this molecule, chloramphenicol, and the antibiotic we talk about. Also, this one. So in organic chemistry, we have what we call trivial names, just like this one. This is the trivial name of this. The IUPAC name of this, following the rule, is going to put this compound as ethane 123, ethane, as some people may call it, ethane 1,2 diol. So molecule with 2 OH are usually called diol, especially when the OH are next to each other. So this is diol in this case, where it doesn't have to be next to each other, but in this case they are next to each other and it is called diol. But the trivial name, that is like it's like saying nickname. So the nickname of this compound is glycol. In organic chemistry, instead of saying nickname, we just say trivial names. Well, trivial as the name implies. So we just give it to the compound, not because it is the right name, but it doesn't follow IUPAC nomenclature, the IUPAC naming system, but it's just a name that have been used in the past, and it continues to remain. So it's called trivial names, and we have them. It's just like this one. We call this isopropanol. Isopropanol. The right name of this, the IUPAC name for this would be propane 2-ol, because the hydroxyl group is on the second carbon atom in this molecule. It's called isopropanol. It's mostly used in the industry as solvent. It's poisonous, but it remains an important solvent, especially in the industry. And we have benzyl alcohol. So don't make mistake, this is not phenol. You can see there's a carbon atom that is bearing the OH group. So in the case of phenol, the OH group is directly attached to the benzene ring. But in this case, the OH group is attached to a carbon that is then attached to a benzene ring. So this is called benzyl alcohol. Benzyl alcohol. So the next thing I'm going to talk about is types. We have different types of alcohol. Types of alcohols. So we can have the primary alcohol, the secondary alcohol, and we can also have the tertiary alcohol, just based on the alkyl groups that are attached, that is connected to the carbon atom bearing the OH group. So as you can see, this is the carbon atom bearing the OH group here. This is the OH group, and this carbon is called the alpha carbon because it's the one that is the carbon that is immediately next to the OH group. It's called the alpha carbon. And how many other alkyl groups are connected to this alpha carbon? That is the question you ask yourself. And the answer to that will determine if this alcohol is a primary alcohol, a secondary alcohol, or a tertiary alcohol. And to simplify this, if you have just one alkyl group attached to the alpha carbon, that is the carbon carrying the hydroxyl group, then you say that is a primary alcohol. If there are two alkyl groups that are attached to the carbon atom bearing the OH group, then you say you have a secondary alcohol. If the carbon atom carrying the OH group has three other alkyl groups attached to that same carbon, then you say you have the tertiary alcohol. Like if you have something like this. Something like this. So this is a methyl group, and you have the OH group. So this is a tertiary alcohol because there is a carbon atom here. And to this carbon atom, you have another carbon atom, another carbon atom, another carbon atom. If you break this down, you actually have CH3, COH, CH3, and CH3. So you have three methyl groups attached to the carbon bearing the OH group. So in this case, you say you have a tertiary alcohol. A tertiary alcohol, and this is actually called tet-butanol. It's called tet-butanol. Let me write it here. This part may have cut out. So this is called tet-butanol. So this is a tertiary alcohol. And so that is where I will stop for today. We'll continue in the next lecture. So in the next lecture, I'll be talking about the acidity of alcohol before we talk about the preparation and the reactions. So I'll see you in the next lecture. And again, my name is Abiodun Ifeoshe. Thank you for listening, and I thank you for your time. Thank you, and see you in the next lecture. Bye.